You are falling. Not slowly, not gently. You are falling faster than anything you have ever imagined. And the strange part is, you don't feel it. That is the first thing nobody tells you about black holes. The falling doesn't hurt, at least not at first. A black hole is not a hole. It is not empty. It is the opposite of empty. It is the most matter packed into the smallest possible space in the entire universe. A star many times larger than your sun collapsed down to a single point. A point so dense that not even light can escape its gravity. And gravity, as Einstein showed us, is not just a force. It is the shape of space itself. So when you fall into a black hole, you are not falling through space. Space itself is falling, and it is taking you with it. There is a boundary. Scientists call it the event horizon. It is the point of no return. Cross it, and nothing, not you, not a signal, not a single photon of light, can ever come back out. From the outside, something extraordinary happens. A friend watching you from far away would see you slow down. Time near a black hole moves differently. Einstein predicted this in 1915. The closer you get to that event horizon, the more time slows from your friend's perspective. You would appear to freeze, to turn red, to fade. To your friend, you never actually cross the event horizon. You just get dimmer and dimmer until you vanish. But from your own perspective, you cross it without even noticing. There is no wall, no alarm, no sudden jolt. You pass the point of no return and everything feels completely normal. Physicist Kip Thorne, who won the Nobel Prize for his work on gravitational waves, describes the event horizon as a mathematical surface, not a physical one. You cannot see it. You cannot feel it. You simply pass through it and keep falling. And then, things start to change. The gravity pulling at your feet becomes stronger than the gravity pulling at your head. Scientists call this tidal force. It stretches you, first gently, then violently. Your body begins to elongate. Your feet accelerate faster than your head. Researchers call this process spaghettification. That is the actual scientific term. You become thinner and longer until the forces rip you apart entirely. For a supermassive black hole, the kind sitting at the center of most galaxies, the event horizon is so large that the tidal forces at that boundary are actually gentle. You could cross it intact. Astronomer Andrea Ghez, who won the Nobel Prize in 2020 for proving the existence of the supermassive black hole at the center of our galaxy, estimates that black hole alone is 4 million times the mass of our sun. 4 million suns, collapsed, waiting. Inside the event horizon, time itself changes direction. The forward movement from past to future begins to behave like a direction in space. You cannot stop falling any more than you can stop time from moving forward. The singularity at the center is not a place in front of you. It is a moment in your future, unavoidable, approaching whether you want it to or not. Mathematician Roger Penrose proved this mathematically and won the 2020 Nobel Prize in Physics for it. Once you cross the event horizon, reaching the singularity is not a possibility. It is a certainty. What actually happens at the singularity is unknown. Our best physics breaks down completely. Einstein's equations produce infinities that make no physical sense. Quantum mechanics and general relativity, the two great pillars of modern physics, flatly contradict each other at this single point. It is the one place in the cosmos where our understanding simply ends. Tonight, look up at the sky. Find the darkest patch of space between the stars. There are an estimated 40 million black holes in the Milky Way alone, invisible, waiting, each one a place where space falls faster than light, where time points in only one direction, where the laws your entire existence depends on quietly stop working. You have been living next to the edge of knowable physics your entire life. You just never noticed the view.